Hello, everybody. Welcome to Enabling Confidentiality in Multi-Cloud Environments. My name is William Bell, Executive Vice President of Products at Phoenixnap. And with me today, I have Bruno Domingues, Principal Architect at Intel, and Patrick Conte, VP of Business Development at Fortanix. Thanks for joining me, guys.
Great to be here, William.
Thanks for having me.
Great to be here with you as well, Bruno.
Absolutely. All right. So we're going to try to keep this really conversational today. We've got some kind of panel-like questions that we're going to go through, but I wanted to take a minute to set the stage about security and specifically security in multi-cloud use cases, right? So everybody knows that as you transition to adopting cloud services, that it's not so much that they can't be made more secure than your on-prem. In fact, I think that evidence is there, and it's very clear that most cloud services do enable you to be more secure, likely than you were on-prem, because there's a much more robust platform of tools and capabilities there, enabling you to better protect your data. However, the way that you address those security concerns is so vastly different in many ways from on-prem and also between clouds. It presents a unique challenge just to adopt a single cloud infrastructure or platform as a service provider. But when you start to adopt a multi-cloud strategy and you start putting your data in lots and lots of places, you really end up in a bit of a pickle. And we're going to talk about why that's the case and maybe some solutions that you can look at to solve that. This number 2.2, when we talk about usage of public and private clouds, we are in this case talking about infrastructure and or platform as a service and not SaaS. That number goes through the roof when you bring SaaS into the equation. But on average, organizations are using 2.2 public and 2.2 private clouds and or different generations. There's lots of ways that the data is classified for their environments, which already presents unique challenges, generational challenges, compatibility challenges, and I think the last one is that's hybridity challenges around how you manage that infrastructure and the infrastructure and resources of tomorrow and the infrastructure and resources of today. And when the Flexera guys talk to customers about how they work to address these concerns, only 33% of people that said they use multi-cloud infrastructure had adopted some type of multi-cloud security tooling. And what that means is everyone else is trying to use the individual solutions available to them in that individual environment. And that can be a daunting task for the security and information security teams. So when we look at this multi-cloud security management challenge landscape, right, we see what starts with the basics, right? The idea of managing data protection encryption across multiple clouds with multiple generations of applications, cloud native and traditional, potentially even mainframe, right? It's hard. And if any of you have ever tried to adopt key management or enterprise key management tool sets just for an on-prem infrastructure deployment and or application deployments, you know how hard this is. And when you start taking those tools and capabilities and try to point them at public cloud infrastructure, very often it either doesn't work or it has major compatibility challenges because those apps were not built for the cloud. We do a lot of work at Phoenixnap to build security into our applications and intellectual property that we develop. And I know firsthand how time-consuming and challenging that can be. Not only to adopt a security-first mindset internally, but also to audit and ensure that the applications that you are building are secure, and are you at least you're doing everything that's reasonable to help protect the code and the applications that you're developing. And we do a lot of this ourselves specifically for protecting our customers' information, but also in order to meet stringent compliance controls. And I think that, you know, as you look at compliance and security and trying to understand how you're going to achieve both of those, they are different things. Don't have time to get into that today, but they're very different things. You need a tool set that's going to be able to enable you across, you know, the infrastructure and application deployments that you have to manage those capabilities, or at least some of those capabilities, from one place. And then ultimately, yeah, you know, when you look at legacy KMSs and things like that, a lot of them are working hard to retrofit things, but they weren't built for the public cloud. They weren't built for data sprawl everywhere, and it can be very challenging to try to leverage them in a multi-cloud world. So we're going to roll right into our Q&A part. Bruno and Patrick are going to help out. Bruno, as I said, is with Intel. He's going to talk mostly about Intel technology. As a technology provider, they're building world-class hardware infrastructure that is silicon, you know, based for predominantly, that is delivering a security platform for guys like Patrick and his teams at Fortanix to build amazing software around. And provide solutions that ultimately you can adopt, or that folks like Phoenixnap can take and deliver as a service to customers. So with that, we're going to roll right into question one. Why is enabling multi-cloud and achieving compliance in the cloud still a challenge for many organizations? And we're going to start with Bruno and just kind of roll from there. Bruno?
Okay. Thanks, William, for the question. Yes, that's the kind of question that's arises very often. That indeed, it's not a new problem. If you're looking in your past and you're looking for IT environment, always when you have a heterogeneous environment, have interoperability and make sure that it's everything is working based on your definition or your policy. It's something always challenging. However, when you're looking for the compliance side of things, it doesn't mean that it's be secure, it's enough. For example, if you're looking for a cloud environment, you can build the most secure environment in the cloud, but doesn't mean that you are compliant. And also, on the other side of things, when you are compliant, doesn't mean that you are being truly secure. So they have this balance when you're looking for a heterogeneous environment, for example, in multi-cloud environments, in the public cloud, and also in your premise environment, it's where reside most of the challenge, how you assure that you have a consistency in those environments. So when looking for many of those regulations that many organizations may have to follow, we can go from financial institutions to healthcare, that it's an element in the challenges, that it's how you protect the key, how you show that you're protecting the key. And of course, if you have to, you have to protect the data, and how you protect the data, use encryption keys. So anyone talking about the keys, you have policies to define what is the length or the strength of the key, what is the frequency that you cycle that key, where you store the root key or anchor key. That is a lot of steps that you have to show that you are using in this heterogeneous environment to protect the data. So I think that it's the major challenge. It's when you're looking for your heterogeneous environment in different clouds as providers, and also how you have a consistent platform that can look across all those environments, and you have one single policy, one single way to manage the keys, and also you provide evidence that you are following those rules. I think that it's the major challenge that many organizations will follow. Of course, we follow for many other topics, but this, I think that it's the challenge number one.
And Patrick, what's Fortanix doing to kind of help enable this and bring solutions to customers with your platform?
Yeah, thanks very much, Will, and Bruno as well. I think there are really three things at play here when we talk about multi-cloud and why it's so difficult to achieve compliance and, more importantly, security, right? I mean, compliance is your check on security, but ultimately being more secure is the most important thing. And those three areas are sprawl of existing platforms. So these could be encryption platforms, they could be other kinds of security platforms, around network security or endpoint. It also could be databases, right? Databases that have to be secure. So I think number one is sprawl of all of these different encrypted entities, let's call them. The second thing is that it relates to encryption in particular. The fact that you've got years and years of agent-based encryption, hypervisor-based encryption, different key management solutions with different scalability levels, different HSMs, and almost in every case, these traditional platforms do not span across clouds. So they're basically designed to work only in the cloud, the private cloud or the on-premise or the cloud environment that they were instantiated in. So they don't travel across clouds. And then I think the third thing is the desire for companies to have movement of workloads, be able to move workloads from on-prem to private cloud, from private cloud to public cloud, maybe even back to private cloud based on what the use of those workloads are, and being able to maintain security of those workloads through all of this. So I think these are really the three key things that have to be solved for. And what we've done is we've used an underlying Intel technology called software guard extensions, or SGX, that lives at the chip level to create a secure enclave in our self-defending key management service that allows us to manage all of the crypto materials out of one place that's fully secure even while it's running. And that gives us the ability to actually be able to protect workloads as they would move from one cloud to another cloud, to have policy follow the workloads, and also to integrate all these other technologies and platforms that have been out there for so long using standard APIs to integrate them into one solution that can be managed from a single pane of glass. So I think those are the things we're trying to help in this regard.
For sure. And I think that, as we look at some of these unique challenges, what we can tell you is that our partners and our customers are looking to use and leverage Phoenixnap solutions, but we're very neutral in the way that we deliver our services. We know that customers are leveraging multi-clouds, and as we work to deliver these new solutions to our customers, we're focusing on enabling protection of the data inside our four walls and helping our customers with protecting the data in other cloud environments. And I think that that's a truly essential component to ensuring that everybody is secure. All right, question 2. What is confidential computing and how does it address some of the challenges that we've been talking about? And we'll start with Bruno.
Okay, thanks for the question, William. Yep, indeed, the confidential computing is something that was born with the cloud SaaS providers, I think, with the internet, but it's something that it's a problem for IT for a long time, because when looking for the ways that you protected the data, we used to have, for example, protection the data at rest. When you encrypted the data to disk, for example, you have database files, whatever you have, and you have this technology for so long time. However, when you transfer that data from one computer to another computer, to one place to another place, for one cloud to another cloud, you always have the encryption in transit. When you use, for example, TLS, when you access, for example, your online bank or your shopping online, you have the TLS connection that is protected the transfer of the data between two points. So But when you have, for example, a virtual environment, you have a cloud computing, and now you are sharing the same compute environment, the same infrastructure, that's where rises the need, for example, confidential compute, because how you can guarantee confidentiality and or that you data it's protected, for example, from another machine that's running the same environment, or even from the cloud SaaS provider that it's, of course, hosted that infrastructure for you. And then, as Intel, we work on the hardware. What Patrick mentioned previously was Intel SGX, software guard extension, that basically can protect the data on use. It means that everything that is inside the secure enclave cannot be accessed externally. It means all that it's running the defined space in the memory, it's encrypted, and the key it's managed in the memory controller. And the memory controller it's tamper proof. It means you cannot go there and of course steal the key, because the hardware guarantee that protection. So with this technology, allow you to have a space in the memory that you can execute your code, you can execute your application, and also you can do remote attestation. It means that you can remotely make sure that it's everything that executes in that space, it's in a trusted space, it's in integrity state. And then that's what you starting talking about a lot about confidential computing, because the rise of this technology that allow you to share an infrastructure environment to, of course, get the benefits of the scaling, but at the same time guarantee that you are running in your own space, that nobody can watch or see or steal the information that's running this specific space in the computer.
Patrick, what are your thoughts on, kind of what the future looks like for confidential computing, and how you and Intel are going to try to work on that together?
Yeah, we work very closely with Intel. I mean, I think it goes, to say that we've really based our own confidential computing approach, which we call runtime encryption. We've based it on Intel's technology, and that secure enclave that can be created in memory that we talked about before. That's a place where to achieve confidential computing, you need to be able to manage your data and your applications while they're in use and have them be fully protected. And as Bruno said, that could never be done before. In the past, you could protect your data at rest with encryption, you could protect it in motion with encryption, but when it got to the destination where you needed to run it, it was in the clear. And over the past few years, that's where the bad guys have been getting our information by doing, some of the new exploits like memory scraping, or, getting, what's called man-in-the-middle attack, getting in between the TLS tunnel and the destination server, or maybe stealing the server outright with BIOS attacks or things like that. And here's the good news. None of those things can affect confidential computing. None of those things can affect the Intel SGX and the runtime encryption that we've built. So what you're able to do now is actually protect data and application for their entire life cycle, from the time that they're at rest to the time that they're in motion, and even the time that they're in use, because the data in motion actually delivers the data and the applications into the enclave. So it terminates inside the enclave. So that helps really address, where those weak spots were in the previous environments. And we're working with Intel on next generation technologies that they're coming out with, later chipsets, and building our software platforms on top of those, including the ability to take those existing applications and data and put them into the enclave without making modifications to them, which makes it much easier to use confidential computing. So those are really some of the key things, to try to achieve the true zero trust environment, as Bruno was talking about, where the security really is separate from the infrastructure. That means that the customer really only has to trust. They really only have to trust that SGX works the way that it's supposed to. They don't have to trust the they don't have to trust the software vendor. They don't have to trust the CSP or even their own admin. All they have to do is just make sure that software gets into that enclave, and then they're protected. So that's how we're working with Intel to make confidential computing more than just what it was a few years ago, which is a couple of words put together, and now make it into a real thing, which is what the industry is asking for.
Yeah, and I know at Phoenixnap we're definitely not there yet, but we're focused heavily on trying to ensure that our future cloud platforms are essentially, set up in a way that customers can have zero trust of our infrastructure while being confident that the data that they put on our infrastructure services, is secure and compliant. And I think that is, it's very hard to kind of wrap your head around to say, I don't want to trust this cloud infrastructure provider, but I also trust them with my business. But, I think for us and others, right, including the hyperscalers, it's an optimal solution for both parties, right? It's a place where we can have some level of indemnification against breaches and things like that, and you can have less worry and concern about an insider threat or something that you have at any cloud infrastructure provider. And I think that, or let me be clear, that you have at any cloud infrastructure provider and yourself, right? Like the insider threat inside of private clouds is potentially even more serious because of less controls and less auditing and things like that are going on in those environments. But, being able to pick up that workload and deploy it to an edge location in rural Africa might be necessary for you and your business in the future. And even the cloud provider is going to have a hard time delivering the same level of security that they can in their monolithic data centers to these edge locations, as proliferate as they may become. So it is something to think about, and I think it causes people in the industry a little bit of pause. People are concerned more than ever about security and data privacy with 5G and edge and Internet of Things. And as you're planning, for those of you on the call, as you're planning, how are you going to control your data in the future with more sprawl, with more copies of the data than you've ever had before? It is something that you should really start focusing on and thinking about. And Intel and Fortanix, along with Phoenixnap, are definitely leading the way in that area. All right. So when we look at, I think this is good for those on the call, right, to maybe get some context for them and the types of organizations that they're in. And I think we're all going to have different answers here. But, Bruno, when Intel talks about the industries that they believe will be first adopters of confidential computing technology, what does that look like for you guys? And who are you talking to help you develop these groundbreaking capabilities?
Well, indeed, actually, I don't think that it's one industry that can afford to do not have confidentiality on the data of their customers. I think all those industries, they have weekly this obligation to keep the data or the information that was generated from the data and private. I mean, when talking private, of course, I'm talking about confidentiality in this sense. But of course, there are some industry that keep the data private or maintain the confidentiality of the data that they collect from the customers. It's not enough. You have to prove that you are doing this, because you're looking, for example, for PCI DSS, that it's a common regulation that many financial institutions may have to follow. For example, if you handle credit card, or for example, in healthcare, you have HIPAA. So you have to prove that you are keeping the data confidential. You have to keep the privacy with your customer. So and then that's exactly the point when you're looking for technology like this, because you can have the best process, you can have the most trusted cloud SaaS provider that you go in with the best software that you have, but you also have to prove that you are following that process. And when I'm talking about confidentiality and privacy, I'm not only talking about the leak of the data. I'm talking about, for example, the change of the data. It's another thing that it's in many industries, it is also a concern because we have frauds and other things. So you have to rely on technology. And for example, in many of this discussion that you have when looking for confidential computing, we're looking to fill that space that exists. How I can make sure that the data that I store, it's in a trusted state with, even if, for example, I am getting this data, what list is storing that data in my cloud SaaS provider. And of course, I do not know exactly what the process they follow there, but I would like to make sure that nobody can access, even my cloud SaaS provider. And then, even if you have the best solution out there, you still have to prove. So that's the reason that, for example, I think that financial institutions and healthcare, they have the highest bar to prove that confidentiality, but in all those industries, they are looking for technology like this because they need it to provide confidentiality for their customers.
Yeah, I think that's an important comment that you brought up, Bruno, around confidentiality and data integrity as well, right? I think as part of confidential computing, we tend to talk about privacy and hiding it from somebody or people that don't need to know, but we also have to focus a lot on data integrity, and there are some capabilities that are helping along those ways and that are at least tangentially related to encryption, etc. So Patrick, when you guys at Fortanix are thinking about different industries, I know you guys have various verticals that are early adopters of these capabilities. What does that look like for you guys? And then I'll add a little bit after that.
Yeah, I think, well, you said it yourself, William, and Bruno did as well. I think the logical vertical markets that are the most, let's call them the most urgent in terms of confidentiality, are financial services and healthcare, and not necessarily in that order. And part of the reason for that is the cost of the breaches in those two markets are higher than in other markets. However, up until about 3-4 years ago, confidentiality of data was really regulated by compliances, right? By HIPAA, by PCI, by maybe Basel II or something like, some of these different kinds of compliances, or maybe a NIST framework or something like that. But as of really a few years ago, when Europe brought GDPR to the table, it changed the entire landscape, and it meant that all personal data had to be regarded as just as important as other personal data. And I think it isn't just Europe now, because California has their own privacy laws, and many countries have instituted their own, the ones that are outside of Europe, and certainly Switzerland and the UK and many places around the world now have data privacy laws that mirror the horizontal nature of GDPR. And what this now means is that it's moved from vertical markets to more of a shared responsibility model between providers and the owners of that data. And so I think which industries need confidentiality the most now is kind of everybody at this stage of the game, because it's a legal mandate. But what industries need to put these confidentiality capabilities in place? I actually think that William, Phoenixnap, as a representative of the service provider space, it's really incumbent on you guys, and I think you guys are taking some significant steps with your your data security cloud and some of the other capabilities you're bringing to the table. But it's really the service providers now, in many cases, who are holding a lot of this data. And so in the shared responsibility model, it's what industries need to help customers keep that confidentiality. And I think service providers are really at the front edge of making this happen.
Yeah, I mean, thanks, Dr. I think that what we're seeing here is adopting adopting widespread encryption, modern data privacy technology, and platforms that enable customers to help or enable customers to have a kind of a central point of management and a cloud-based consumption of these capabilities is really going to help drive the implementation down market from the largest enterprises that know they have to do this, that are heavily invested, that have, billions to lose if they can't get this right, into the folks that, might have been putting off implementing technologies that help with confidential computing, that help with the encryption and data security in favor of more traditional things that still need maintenance, right? Endpoint protection and firewalls and things like that. So, at Phoenixnap, that's really our hope, is that we can help put these technologies in the hands of people that might otherwise be, kind of taking a slower pace in adopting them. So thank you guys for that feedback. All right, and the last question for our panel today is, maybe a little bit more targeted. I want to get into some of the technology. I know you touched on a little bit of this, Bruno, but maybe you could help us understand better exactly what Intel's doing to help enable confidential computing, and then I'll let Patrick talk about their integrations with those capabilities.
Okay, I think that's a good topic. I don't want to get into much technical details, but as I explained in the beginning, there is a need for have a trust execution environment in computing for a long time. It's not for just now. And when you look in the spectrum of the technology that it's have this kind of capability, for example, if you have your phone, you have a trust execution environment that, for example, they can store, for example, your fingerprint. And that's something that you trust because it's your device, and that one, the provider that it's authenticating, you use that as well as a middleman that it's everybody trusts, and the data keep that. So when you're looking for cloud environment, you have the same thing. So we need some place that you can store the data, or store, for example, the encryption keys that you can trust, and doesn't matter whether you're executing. So if you go down to the platform level, what we did, we create in our CPU, and because we have in the CPU the memory controller, we included the capability to encrypt specific areas of the memory, and only you, as the owner of that application, that section of the application that's running in memory, you have access to that memory, or have access to specific about these encryption keys. And then we create this platform, but or this technology, but of course it's not enough to deliver this confidential computing capability by themselves. But we included these capabilities in desktop notebooks. Probably if you have a 3-4 years old computer, you already have this technology on in the desktop and notebook, and you bring this also for the servers. So we have on the platform ZenWe3, you are launched the end of this year the Ice Lake with the code name that we have into socket machine, and having the hardware is not enough as well. So that's the reason that work, for example, with partners like Fortanix, that build their platform on top of this, their software that can extract the value of this technology that we develop in the hardware. Otherwise, there is no confidential computer. You just have the ingredient, the component. So with this, the Fortanix is delivering the capability of course, exploring some of those potentials that we have in this capability, that the confidential computer become available for users.
Absolutely. And, I think, Patrick, I don't think it's a stretch to say that Intel is the most important partner, hardware and technology partner that Fortanix has, right? Maybe just partner in general. But maybe you can expand on a little bit of what Bruno was talking about.
No, it's not a stretch at all, William. And in fact, in all, I guess in all transparency, Intel was a customer of Fortanix before they were a partner, and is also an investor in the company. So, but all of that happened after they were a customer of ours. And the interesting thing is that the use case is one we've already talked about before, which is that Intel had a whole bunch of different security technologies that were all running different kinds of operating environments and different administrative environments and everything else, and they needed to integrate them into one platform where they could manage them from a single pane of glass, especially as it related to things like hardware security modules and things like that. So, you know, that's something that we brought to the table, and I think that led to, you know, the stronger levels of partnering that we've done with Intel. But you know, we were the first company to build a commercial platform on top of Intel's SGX chip level technology. And, you know, as I said, we call that platform runtime encryption. Includes a development platform, includes a runtime platform, and basically allows customers to either develop applications specifically for running in the trusted execution environment from scratch, as we did ourselves with our self-defending key management service. We built that application ourselves with our own tools, or they can use our products to wrap their existing applications and data and put them into the enclave themselves. So yes, Intel is definitely our most important partner in this regard, and we work very closely with them. I think you could think of what we're doing as really extending what the core technology was designed to do. And when everything is said and done, William, there's only one technology that's been proven to protect your data, and that's encryption. All the other things that we do in security, and I've been in security for, you know, a couple of decades, are kind of mitigations, right? You know, things that we do at the network level or maybe at the endpoint level or some of these other things. But when it comes to protecting the data, only encryption has been proven to actually be able to do that in any case. So how do we make encryption stronger? Well, we use the kinds of technologies that Intel has developed, which exist at the chip level. And that means that even if the system itself is compromised, if somebody gains root password to the physical box, or they gain access to the BIOS or whatever, you still can't steal the data. It's still encrypted. It's still protected. So this is the kind of thing that is only going to get better and stronger over time as Intel brings out new chipsets such as the Ice Lake that Bruno talked about, with more cores, more chips, more memory. And that means that more different kinds of applications will be able to go into those enclaves, such as advanced analytics and different kinds of healthcare, maybe fraud detection, and other kinds of applications that require some type of AI or other algorithms. You'll be able to put data and applications into the same enclave with the newer technology. So we're already building these kinds of situations out in proofs of concept, and so the marketplace will be ready when the new stuff comes along.
Absolutely, and we're really excited about that. I mean, there's definitely a lot of great things coming down the pipe, and a lot of different ways that that both the software that Fortanix is building and the technology and hardware that Intel is enabling are going to help us as a cloud provider and ultimately our end user, realize some of the capabilities and benefits that we've talked about today for their businesses and their applications. So. And I want to thank you guys for taking the time to be with us, talk to us a little bit about the technologies that you both have mutually developed, and then at the end you'll stay around and answer some questions for us. Sound good?
Sounds like a plan.
All right.
Happy to do so.
Perfect. So, Patrick touched on this a little bit. We've been working for the last 2 years to build a secure cloud infrastructure service that is built with security by design. right? Really trying to ensure that as customers move workloads to the platform, they're getting an immense security and compliance upgrade via that migration, and a host of tools that enable them to, not ignore security, because you just can't. There's too many company-specific reasons to think about security every day, but maybe take a little bit of the load off. Feel like the platform has a lot of integrated tools at their disposal, and we're continuing every single day to try to make that better, right? So we take a secure and audited hosting platform and cloud infrastructure platform. We bring in all kinds of segmentation controls and technologies to help separate customer data from one another. We bring the full power of our partnership with Intel to the forefront to ensure that customers have the best performance and availability possible in a cloud service. Layer in the next generation software-defined networking capabilities that our partners at VMware have been developing for years now with their NSX platform, and truly provide a resilient and capable infrastructure platform that is helping customers protect their data in every way possible. And so as you look at kind of the high-level architecture of the platform, we have a lot of different things going on behind the scenes. Not all of them make them up to the customer experience, and we're going to talk about a new one that we've built that as well may not be readily visible, but do help with trust and assurance of a platform. And so, this high-level architecture talks about the things that we're doing already. Where we're going with the platform and what we've been working on for the last few months is integrating high performance and scalable encryption as a managed service on this platform, so that customers, once they've completed that migration or they start building new applications in the platform, can then be assured that their data is encrypted while it's running and at rest as well. So that's really where we're going. That's what we're working on to help people get that kind of by default. It's not something that you should have to think about, as you configure different services. It's something that for a secure and compliant computing platform, you should just be enabled and turned on. So that's kind of what we're working on there. And we're leveraging our partners at Fortanix, who are working with their partner at Intel, our mutual partner at Intel, and bringing this HSM, this hardware security module backed security footprint powered by SGX as the secure key store for the managed encryption that we're delivering on top of Data Security Cloud, and various other different capabilities that I'm going to kind of highlight. Not only are we able to provide that kind of just default turned on encryption of virtual machines, we also are working hard to enable you as a customer or a partner to have an external key management server that is actually interfacing with our KMS in order to provide the keys to encrypt the data inside the cloud computing platform. And I think that that's really integral to starting down this route of confidential computing. Like at that point, we're not part or party at all to the generation of the key material, right? In our managed encryption, we are, right? It's happening by Fortanix. It's self-defending is what Fortanix calls it. We don't actually have access to the key, but our systems are in fact generating the key, right? And the software that Fortanix has built is generating the key for that. So there's this kind of give and take. that's going on, and a continual improvement. That's where we're going. That's what we're showing. And as you take that out of the data security cloud construct, the ability to interface with this platform from your application, from your database, from your cloud native infrastructure deployment, regardless of where it is around the globe, on-prem, in AWS, in Azure, right? Wherever it is, as a colo customer in one of our facilities, you will have access to be able to manage the life cycle of your own encryption, your own secrets in a cloud native construct, and some other capabilities that are important for a lot of your application developers, like tokenization, like transparent database encryption. So these are the things that we're bringing to market, that we're going to be deploying over the next few months and bringing them to our customers, and for those of you that are on the call that are partners, to your customers as part of our platform, right? And the number one most important thing is that you have control, right? You are still in control of the data. You're still in control of the encryption and capabilities that we're delivering as a service. So we deliver it in a pervasive manner. It is going to be available from anywhere, over RESTful API, over key management exchange capabilities. There's a host of protocols we're not going to get into today, but trust that you will be able to interface with this platform in a multitude of different ways. You're going to be able to stay in control of your encryption and data privacy and data security, regardless of where that data is. And although we're going to be assisting with, at least in some use cases, the generation of those keys and the management and life cycle of those keys, they're still under your control. They're still going to be able to be rotated and or generated based on your definition. So before we jump into the Q&A, I lost something here. I lost my GoToWebinar control panel. But before we get into the Q&A, I wanted to toss up a poll question so that our cracked marketing team can have an understanding of kind of what everyone thought of the presentation today. If there's any of the solutions that we talked about, whether you're a Phoenixnap customer and you're interested in deploying them on our platform, or just the technologies themselves, let us know if you want us to reach out or discuss some of these solutions. We can bring in the guys from Intel, we can bring in the guys from Fortanix, and after we get some responses here, I will go ahead and shift this over to Q&A. If you've got any questions, if you've got any things that you are burning through this whole time, throw them in there. We've already got a few to address. I know we're running out of time, but I feel like this has been a really powerful, webinar. And I'm going to bring my friends back in. I'm going to close this out here in just a second. Run to get them in. Okay, here we go, closing it down. And we are going to do some questions. All right. All right, the first one is for Patrick. As customers are developing applications, right, what ways can they interface with Phoenixnap Kms powered by Fortanix? And how can this help them kind of get quicker to market or quicker to resolution as they try to build security encryption in their apps?
Yeah, excellent question. So self-defending a key management service, which is going to become one of the foundations of your data security cloud as you go forward, and offering encryption across the board has the following capabilities. We can do our own encryption using our own keys. So data at rest and data in motion, we can do those without there being any agents or any other encryption capabilities necessary. We can manage all of the keys for all the different encrypted entities, VMs, vSANs, other kinds of hyperconverged entities or non-VMware VMs. I mean, pretty much anything that can be encrypted, we can encrypt and key manage, as well as databases, which is a huge thing, right? I mean, a lot of companies have many databases, and the key operations are very, very rapid, high velocity, and you need something that's cloud scale. However, specifically to your question, how do you interface? There's a ton of extensibility with self-defending key management service. Number one, it'll scale essentially linearly to handle as many entities as the customer would have, and you guys have the ability to just add on capability and take care of those things for customers. Secondly, basically any kind of API that exists in the security world today, from KMIP, which is a big one, to PKCS 11, which is used a lot with HSMs, full package of REST APIs, and a number of other ones are all standard in self-defending KMS and are exposed so that they can be easily connected into existing applications, such as, for example, a SIM or something like Splunk, where we have standard connectors. We also have the ability to extend the actual capabilities of the product with what we call plugins. So plugins use a simple scripting language and allow you to create new applications, could even be a new crypto algorithm, or it could be a workflow, or something specific, a set of filters, an API gateway. You could create any of these things with a simple scripting language, and then once you plug them into self-defending key management, then those operations are all done inside the enclave as well. So again, those are all fully protected, and they're all fully cryptographically separate from one another. So that's how we would help customers to extend and utilize the product, would be to connect into anything that they've already got, as well as be able to add features and capabilities via plugins.
Yeah, I mean, I think that we're focused on delivering a very multifaceted platform. We're happy to have you guys a partner and building kind of security not only into the infrastructure but also into the applications that folks are developing. We had another question that talked a little bit about thank us for the information on SGX, and then ask if there was anything else that Intel's working on, maybe some next generation enhancements. Bruno, maybe you could cover a little bit of that. We're a little short on time, but we'll take whatever we can get.
Okay, excellent. Let me take this one. Well, when you're talking about SGX is one instruction, one extension that you have in the CPU that can allow you to create the secure enclave after this discussion today. And of course, we have the next generation capability that is coming to SGX that can increase the amount of memory that you can allocate to SGX. But also, we have been working on different extensions. Not necessarily it's going to replace the SGX, but can give something different. Like, for example, what we're going to launch, it's another thing that it's called TDX, a Trusted Domain Extension. Trusted Domain Extension, it's like for, imagine, I like to make this analogy. It's like, for example, imagine that you have a condo. If I protect the whole system, I mean, it's like the whole building. And then if you go to each apartment, it's like TDX, Trusted Domain Execution. For example, I can have one virtual machine run inside, for example, that's an apartment, and it's all protected. It's what protect the application. And then it's like the vault inside the apartment. It's like we have different technology, because the problems and the workloads are different as well, the requirement that they have for the hardware. So we have a technology that you present, for example, William, you present one of highlighted that was, for example, Intel TXT Trace Execution Technology is like I can guarantee what at least make the assurance that is the whole state of the hardware, it's in a trusted state. And you have SGX that protect the application or the keys for HSM that you are executing KMS. And next year we are going to have this TDX that you can transparently protect tenants from different tenants without have to change the application. That's the kind of evolution that we can disclose for what's happened in the next few months.
Perfect. Thanks for that overview, Bruno. I mean, we're really excited about where things are going. We think that we're closer than ever to being able to take kind of workloads from customers that they possibly wouldn't normally move out of their environment and migrate them to a cloud service that is going to provide them with that level of trust and assurance. All right, I think that kind of wraps it up. Thank you everyone for attending. You know, we had a really exciting conversation. Thank you to Bruno at Intel, Pat at Fortanix. You guys are awesome. Hopefully we were able to bring you know, a lot of these technologies to the table. We have some handouts at the bottom of the webinar. So if you go down to the bottom under handouts, there's some handouts there. And then our teams are available in all various social medias and the like. And I'm gonna throw up our contact information there so everybody can jot it down. If anyone has any questions, don't hesitate to reach out. And I wanna thank everybody again for joining. Have a great day.
Thanks, everybody.